Hello, great minds. Good afternoon. In today's class, we're going to be talking about the second method of evaluating the limits of functions, and that is the factorization method. Now, when do we use the factorization method? We use the factorization method mainly in rational functions like this. So here, at the top of this rational function, the numerator, we are having x squared minus 4, and at the denominator, we're having x minus 2. And we have to evaluate the limits of this function as x tend to 2. Of course, if you have seen the video substitution method of evaluating limits, you'll see that in the functions we had there, we simply substituted the value for x into the function, and by that, we're able to calculate or able to evaluate the limit. But in this case, if we use direct substitution and we put we put 2 in place of x, we're going to be having 2 squared minus 4 over 2 minus 2. So if you do that, that means we're going to be having 4, 2 squared is 4, so we're going to be having 4 minus 4 over, and the denominator, we're going to be having 2 minus 2, which will give us 0. At the top, we're going to have 0. So if you use direct substitution here, what we're going to be having here is 0 over 0. And we know that that is undefined, that is indeterminate. We can't have a function like that. So what do we do in this case? We introduce the factorization method. Now the idea is for this rational function, we want to try as much as we can to get a single answer or a determinate answer for this function. That's for the limits of this function. So that's where factorization method comes in. So in order to solve this, the simple thing we do is we look at the numerator and the denominator and we see where we can factorize. When we factorize, we can now do some cancellation and we can then take the limits of what is left as x tends to 0. So the first thing you do is you factorize. In this case, you factorize the numerator. When you factorize the numerator, you can now cancel out. When you cancel out, the function that is left, you evaluate the limit of that function as x tends to 0, as x tends to 2 in this case. Okay? So solution. So this is x squared minus 4. X squared minus 4 is a problem of difference of 2 squares. So to factorize this becomes the limit as x tends to 2 of x squared minus 4, like I said, is difference of 2 squares. So it becomes x minus 2 multiplying x plus 2 all over x minus 2. Okay? So we are having this. This is the problem from difference of 2 squares. Now, since we have this, x minus 2 at the numerator cancels x minus 2 at the denominator. So when you do that, you see we are left with x plus 2. So since we are left with x plus 2, this function becomes the limit. That means we're evaluating the limit as x tends to 2 of this function x plus 2. So this is what we have left, okay? But we're now evaluating the limit of this function. So with this, you can see at this point, we can simply use direct substitution to put x as equal to what? As 2, okay? So simply use direct substitution when you've gotten here. So just put x as equal to 2. So if you do that, this becomes, you put x as equal to 2. That is direct substitution method. So then this becomes limit as x tends to 2 of x plus 2 is equal to what? 2 plus 2 becomes what? 4. This is the answer to this problem using factorization method. Okay, so we have to take another example quickly on something similar, then we can use that to show further how we can use the factorization method. All right, here we have our second example here. We ask to evaluate the limit of x squared minus 4x plus 4 over x minus 2 as x tends to 2. Now to evaluate this, you can see at the numerator, we still have a quadratic function at the numerator, while the denominator we have a linear function. to factorize this, we are going to use the concept of factorization, of course. So we have to factorize the numerator and see if you can cancel out so that we can evaluate the limits as x tends to 2. So in order to do that, we start solving. So this becomes the limit All right. Now, let us factorize this numerator. Okay? Let's factorize this numerator. All right. I'll write x squared minus 4x plus 4 over x minus 2. Now, this is equal to... Now, to factorize the numerator is quite easy. We have to look for two numbers that when we multiply them, we have positive 4, and when we add them, we have negative 4. So, of course, those two numbers are minus 2 and minus 2. So, this then becomes the limit as x tends to 2 of this function x minus 2 and x minus 2. Okay? All over x minus 2. So, this becomes the function then is factorized to this. Okay? You can try to expand this. I can check our videos on expansion to see how we can expand this to get back to this function up here. So what we have here, we can see we have x minus 2 at the top and the bottom, so we can simply cancel out. Okay? So if we cancel out, we're left with the limit of x minus 2 as x tends to 2. So this is what you're left with, okay? So in this case, we can use the direct substitution to solve for the limit. So if you do that, this becomes, just put 2 in place of x. So if you do that, this becomes 2 minus 2 is equal to 0. So this is the answer. This is the answer to this problem on limit. This is the answer to our problem on limits. Okay, so I'll give you one to try out and you solve it and show me that you have really understood how to evaluate limits. Evaluate the limit of this function. Evaluate the limit of x squared minus 16 over x minus 4 as x tends to 4. So we're going to take a pause right now while you try it out. All right, so let us get back to solving it. I know you must have tried it and your answers are correct, but let's solve it on the board. To solve this, this is also a problem of difference of 2 squared, so you just need to factorize the top and do a cancellation between the top and the bottom of this function. So this becomes the limit as x tends to 4 of x squared minus 16, difference of 2 squared, is same thing as x plus 4 multiplying x minus 4 all over x minus 4. So when you have this, you can simply cancel out. So when you cancel out, you're left with x plus 4. So you're evaluating the limit as x tends to 4 of this function x plus 4. So from here, you can just do direct substitution. You put 4 in place of x, and this becomes equal to 4 plus 4 gives us 8. So this is the answer to this problem in limits. I hope with this video you are able to understand how to use factorization method to solve problems in limits. And if you find this video helpful, please like, subscribe, and share it to your friends. Thank you.